Welcome to session 13. This is our final session of part 1, and we are going to take a look at something called regenerative braking, which is used in today's electric automobiles and hybrids to recover the kinetic energy from our vehicles when they're coming to a stop sign or a signal, or perhaps even going downhill where we can recover that energy, put it back in the battery. So what we're going to use in our demonstration is this motor, which will also function as a generator. Of course, it has the commutator rotor with the brushes, and the field, magnetic field, is provided by permanent magnets. We have the battery, 12-volt battery, and some meters that will tell us how the electricity is flowing, how much, and we're going to be flowing electricity in both directions. When it's negative, there will be a little negative sign here that you can't see on the screen there. So it's so tiny. What I've done is I've added this little analog device here, and when the needle is straight up, there's no amps flowing. When it goes this way, the battery's providing the energy. When it goes this way, we're charging the battery. Okay? That way the battery's providing the energy. This way we are charging the battery. So let's get started. I'm going to turn on the power to the motor, and we're using about 1.5 amps. We have about 11 volts. This is the voltage at the motor, not the battery. We have some voltage losses, small voltage losses in the wiring. So we're using 1.5 amps. Therefore, when you multiply volts times amps, about 16, 17 watts, I guess, to do nothing, just to overcome the friction of the two gearboxes, the brushes rubbing on the commutator, the bearings, and so on. Now, what if I had to use this to actually do something useful? Like, what if it was operating a power saw, okay, a power circular saw, or we were drilling holes in wood, or it was driving a compressor or a fan? It wouldn't run this fast. The load would slow the motor down. So to simulate that, I'm going to grab the handle and I'm going to slow down the motor. I want you to watch what happens to the amperage when I slow the motor down. Look at that. We more than doubled. In fact, if I slow it down some more, it's almost like we've tripled the amperage. That battery is running down much faster than it was when it was just running without a load. Why did it do that? Why did the amperage go up when I slowed the motor down? Well, let's take a look at something you've seen before. I think you remember this. We saw it operate as a motor. And we saw it operate as a generator. Now, the important thing is that while it's operating as a motor, it is also generating that voltage. I just pulled this off of the battery terminal and touched this motor, the lead from this motor, to the brushes here, and this generated electricity to produce this. That process is going on simultaneously. It is working as a motor, and it is producing a voltage that goes in the opposite direction of the battery. So we have battery voltage and spinning motor voltage pushing back on the battery voltage. And of course, it can't catch up to it. If it did, the motor would stop spinning. So it's always going to be a little bit less so the motor can keep spinning. Now, when I grab the handle here, when I slow this down, the amperage went up because I reduced the voltage from the spinning rotor. The rotor was spinning at a lower speed, producing a lower voltage. The speed dictates how much voltage I produce, everything else being equal. So as I slow it down, I lower the voltage, the battery is able to push more electrons through the motor. What do you suppose will happen if I grab this handle while it's spinning and go faster than the motor wants to go? Let's try that. Okay, right now we're just overcoming friction, a little over 1.5 amps. Discharge over here, okay, discharge. Now I'm going to speed this up a little bit. About 0 amps there, and that's what the needle indicates. It's very neutral. And now I'm going to go a little faster. So now we're charging the battery. And now we're back to being a motor again. And I didn't really do anything mechanically to this, right? We didn't take it apart and change anything. It stayed completely the same. All I did was vary the speed, okay? Well, that ability for this to be a motor or a generator is what makes regenerative braking work in our electric cars and our hybrid cars. Now, I know you're smart, so you're probably going, wait a minute, to charge that battery, you had to go faster. The car doesn't go faster when you're slowing down, it goes slower. If the car goes slower, the motor is going to go slower. You're right. What electric cars have, and I don't here, is very complex, sophisticated electronic devices that do something with the voltage. We don't create energy, okay? It's not magic. Power is not voltage. Power is volts times amps. And what these electronic systems do between the battery and the motor generator is they trade amps for volts. So as the car is slowing down and therefore the motor acting as a generator is slowing down, we are still producing enough voltage to charge the battery. It's going to be less and less and less because we are trading away a lot of stuff, but we're still able to charge the battery at low speeds. This is a smaller, simpler version of an electronic motor controller than you would find in your modern electric or hybrid vehicle. And today we're going to use this to demonstrate how we can recover the kinetic energy of a vehicle through our motor generator, even though the motor generator is producing a voltage that's lower than the voltage at the terminals of our battery. So let's take a look at our setup here. You've already seen how the motor generator works, that we don't have to change anything mechanically to make it work. We've tied it through this axle to this mounted tire. The mounted tire represents the inertia of an automobile. So what we're going to do is we're going to accelerate the wheel using our motor generator as a motor with our battery supply. And then when we got to full speed, we are going to apply our electronic brake essentially and try to recover the kinetic energy of the wheel in our battery. Now it won't last long, it'll last about 5 to 6 seconds. Like when you're coming to a stop sign, it doesn't take that long to slow down, and there isn't that much inertia here, and I have more friction than I wish I did. But it'll still demonstrate the process. Let's take a look at the rest of our system. This will include our measuring instruments. So we have really two sets of measuring instruments here. We have these 2 meters, which are tied to what's going on with the motor generator, the voltage at the terminals of the motor generator, and the amps that are flowing through it. And then these 2 meters are measuring what's going on with the battery. The electronic device has decoupled the two. So now, one of the problems we have in videoing this for you to see what's going on is that when the electricity is flowing from the batteries, you'll see a negative sign right here, and maybe here, which is probably not really visible to you. When the flow reverses, the negative sign goes away. Not very clear. So what I've done is I've included this little homemade device here. It's a little analog device. And when the batteries are producing the energy, this little needle will go to discharge. And then when we apply the regenerative braking process, you will see this go to charge. Now I'm going to do the experiment a couple of times. Like I said, it only lasts about 6 seconds. So I'm going to do it a couple of times, calling out specific things that I would like you to look at. Okay? So let's start. I've got that on, that's on. All right, here we go. We're going to use this little potentiometer as if it's the gas pedal and the brake pedal. Okay? So let's start it up. You notice that we're accelerating, so there's a discharge. There's a little bit of electricity flowing here. These will not match because the electronics decouples them. They do not match. The voltages, see the voltage at the battery is almost 32 volts, a little under 32, and yet the voltage at the motor is only 6. I'm not driving it very hard. We have a discharge. So let's get this thing up to speed. Pull this away here. Okay, now we're going to slow it down, and I want you to watch what happens right here. Okay, so all during that time, we were charging the battery as it slowed down. Now let's go through that process again. And this time I'm going to call your attention to what goes on in this meter. Notice that the voltage is 31.7. That is the highest voltage that these batteries can put out under their present charge. Now we're going to accelerate the wheel like we did before, and when we go into regenerative braking, there's going to be a short period, where we're going to actually exceed the battery's voltage. Okay, you ready? Here we go. Oh, we've got to turn our switches on. All right. Okay, we're at full speed now, and we're going to go into regenerative braking. Watch this meter here. We actually hit 32.7, which is consistent with this meter going to charge and the electricity going in the opposite direction. We have to have a higher voltage if we're going to charge the battery. All right, We're going to do it one more time to show you one other relationship. So this time we're going to repeat the process, except I want you to pay attention to what's going on right here. So I want you to notice that the voltage, the maximum voltage at the moment that these batteries can put out is 31.5 volts. And what we're going to do is accelerate the wheel again, but then when we go into deceleration, regenerative braking, we're going to see the voltage that this motor generator is providing. And you'll see how different that is from here, and even though it's much lower, the electronics is going to allow us to charge this battery. Hopefully we'll see the 32 range if I'm careful enough. Okay, so let's start it up. Okay, now we're going to go into regenerative mode. Notice the 2 volts as we reduce these. Okay, I hit 32 there, and I think we were around 14 or 15 up here simultaneously. Or maybe less. So even though the voltage at the motor was low, the electronic device allowed us to put some of that energy back into the 32 volts of the battery. So that's the demonstration of regenerative braking. Now the quality of what's going on here is not the issue. I just wanted to show you that we have electronic devices that are capable of doing that using the characteristic of motors that can be both motors and generators. Okay? Now, none of the modern vehicles are using this type of motor generator. They're far more sophisticated, more efficient, but for this type of demonstration it would be very difficult for me to use the more complex brushless motors or induction motors or so on. So this pretty much makes it an easy way to show how we can go from motor to generator and back, which was the intent here. Well, I hope you enjoyed this session. It is the end of part 1. In part 2, we're going to be dealing with the kind of electricity that comes to your house. It's kind of different than what you get out of a battery. It's called alternating current. And we're going to look at some various devices to make that a very practical kind of electricity, because we can move at long distances, hundreds, even thousands of miles. And in that process, we're going to learn about certain devices that are kind of not only interesting, but kind of fun to watch. So I hope you'll join me then. So you take care.